Okay, for question number 21, part A, we have to find the domain of y is equal to sine inverse x square minus 4. And this is part A. So we know that when y is equal to sine inverse x, then the domain is, then our domain is -1 domain. That is, x is greater than equal to -1, but less than equal to 1. Similarly, in this case, the domain remains the same, so it's the sine inverse function. So here y is sine inverse x squared minus 4. So domain is, that is, x squared minus 4 should be greater than equal to -1 but less than equal to 1. Now, which gives me this becomes 3 and x squared it becomes 5. So if I remove the square and take the modulus, that is a positive value of x, that should be somewhat like this. So modulus of x should be greater than root 3 and less than equal to root 5. Okay, what does this mean? So when modulus of x is greater than equal to root 3 means that, so let's draw the number line, and modulus of x when it's less than root 3, and let's say this is the negative root 3. Okay, so this is the case when x is less than equal to, so when x is less than equal to negative root 3. So less than equal to negative root 3 means, let's say we have this here -4. So modulus of -4 is equal to root 4, which should be uh, which is the positive value. So x square modulus of x is greater than equal to 3. This is greater than equal to root 3, or x is greater than equal to 3, greater than equal to root 3. So because when x is greater than equal to root 3, let's say when it's root 4, so modulus of root 4 is root 4, and this root 4 would be greater than equal to root 3. Okay, now for modulus of x is less than equal to root 5. So in this case, this would be the case when x is greater than equal to negative root 5, or when x is less than equal to root 5, because the modulus of negative root 5 is equal to root 5, and root 5 would be less than x, less than or equal to root 5. Now, when x is greater than equal to root 5, this value would be, so this is the case, these are the cases when x is greater than equal to negative root 3, and or x is greater than equal to root 3. And when for modulus of x is less than equal to root 5, x should be greater than equal to negative root 5, or x should be less than equal to root 5. And if we plot this on the number line, so this is, let's say, negative root 3, here is negative root 5, here is root 3 and root 5. So for the first one, when x is greater than equal to negative root 3 is this region. Okay, and x is greater than equal to root 3 is this region. And for x is greater than equal to -5 is this region, and x is less than equal to root 5 would be, so in both regions. So if we check, so we have the common region, we got the common region as this one. So for less than equal to negative root 3, this is the region. X is greater than equal to root 3, this is the region. And x is greater than equal to negative root 5, and greater than equal to negative root 5 is the region. And x is less than equal to root 5 is this region. And we have the common region. We are getting the common region as this. So this is the domain is the union of these two regions. So we can say that our here, domain here would be the union of these intervals -5 to negative root 3 and its union with root 3 and root 5. The domain is, and these we can also include values as well. So let these be the closed intervals negative root 5 to negative root 3 or root 3 to root 5. So this is the domain union of negative root 5 to negative root 3 and into root 5.